Good morning, students. Welcome back to yet another lecture on input modeling. This is part 4, where I will be going to discuss on goodness of fit test, in particularly the Kolmogorov-Smirnov test. The last class we have seen two cases, that is the problems on two cases of chi-square test. In this class, I will be dealing with Kolmogorov-Smirnov test to check whether the input model or the random numbers are accepted or rejected. Along with that, I will be discussing some of the terminologies selecting input models without data, and after that few topics or few terminologies from chapter 11, that is a continuation of estimation of absolute performance. The estimation of absolute performance, this chapter is there in module 5 as well as module 4. Some topics are there in module 5 and some few of the topics are there in module 3. So which are the topics which are there in module 4 we will see, and the topics which are there in module 5 also we will see later. So let us begin with this part 4, that is Kolmogorov-Smirnov test. Yeah. So before going to see this Kolmogorov-Smirnov test, goodness of fit test for exponential distribution, that is uniform distribution. Let us see why we are going for this. What were the disadvantages? What are the problems with chi-square test? So there are few disadvantages associated with chi-square test. Yeah. The chi-square goodness of fit test can accommodate the estimation of parameters from the data. The resultant decrease in the degrees of freedom. So we know degree of freedom, that is k minus s minus 1. If the parameters are more, the degree of freedom will definitely be reduced. And the chi-square test requires the data to be placed in class intervals. And in some cases, for continuous distribution assumption, this grouping is arbitrary, right? Also, the distribution of chi-square test chi-square test statistic is known only approximately. The statistics of chi-square test are known only what approximately, and the power of the test is sometimes rather low here. That's why we are going for another goodness of fit test. That is Kolmogorov-Smirnov test. The name itself is telling Kolmogorov-Smirnov test. This method has been proposed by two scientists, Kolmogorov and Smirnov. They have published a paper on this. So I left this as an activity for the students to just go through what was the background of publishing this method from these two scientists, Kolmogorov and Smirnov, why they published in what paper, what was their findings. So let us begin directly with the procedure of Kolmogorov-Smirnov test. First point, this test is useful when sample sizes are small and when no parameters have been estimated from the data, right? So the procedure is this, it's very clear. Uh, Please watch carefully. So first point is, this is for uniform distribution. That means what, the data, whatever the data we have been given, that should be uniformly distributed. Whenever you find the word uniformly distributed data, then we need to apply Kolmogorov-Smirnov test to find the whether the input data is accepted or rejected. Right? So this uniformly distribution is for exponential distribution. So what is the first step? Calculate the arrival points. How to calculate the arrival points? There is a formula. R of I is equal to T1 by T. The next R of I will be T1 plus T2 by T. Next will be T1 plus T2 plus T3 by T. Next will be T1 plus T2 plus T3 plus T4 by T. So on, it goes on like this. T1 plus T2 plus dash dash up to Tn by T, where T is the interval given and Ti is the ith sample data. So ith sample data, we will be having n sample data. So we'll starting with the T1, T2, T3 up to Tn. So we'll see how to solve the problem, how to use this formula. So the first step is to calculate inter-arrival points using this formula. Second step, we need to calculate two things, that is the d plus and d minus. What is d plus? D plus is nothing but we need to find I by n minus Ri. Ri we just calculated from the above formula, where what is I? I is the value which will range from 1 to n, right? I ranges from what? 1 to n. Then what is n? N is the total number of data values given. For example, if he has given 10 data values, n value will be 10. If he has given 20 data values, n value will be 20. So that means what? I will range from 1 to n, the total number of data values given. That is important. And n is the total number of data values. So using this, we need to find out for I is equal to 1 by n minus r1. When I is equal to 2, 2 by n minus r2. When I is equal to 3, 3 by n minus r3. So we need to find the individual values this of this. We will tabulate this, and out after finding I by n minus ri, we will find out which is the maximum value out of that. So that maximum value will be the d plus. Similarly, we need to find ri minus I minus 1 by n, another value d minus, that is ri minus I minus 1 by n. When I is equal to 1, so r1 minus 1 minus 1 divided by n. When I is equal to 2, r2, this is I actually, this is I, not 1. Yeah, this is I. Ri minus r1, I minus 1 by n. When I is equal to 2, r2 minus 2 minus 1 by n. Like this, we have to go and find. So that we will, after finding this, what is the maximum value out of this? That is, that maximum value out of that is what, d minus. So while finding this d plus and d minus, we will use a table like this. So I, as I said, I ranges from 1 to n. N is the total number of data values given. 1, 2, 3, 4, 5. If n value is 5, 1 to 5. If n value is 10, we get 10 rows like 1, 2, 3, 4. Ri is nothing but when I is equal to 1, r1 value, whatever the r1 value we got. When I is equal to 2, r2 value, whatever the r2 value we got. Like this up to when I is equal to n, what is the rn value we got. Why we are doing this? Because we want this to find. So for finding this, I require ri. I require I, right? So similarly, I by n. Why I am finding this? Because that is there in this formula. I by n. I value will be 1 first, then n value is the total number of data intervals. For example, if it is 10, 1 by 10, 2 by 10, 3 by 10, it goes on like that. Next, after that, I minus 1 by n. So you'll find out I minus 1. I value initially 1, 1 minus 1 divided by n. 1 minus, sorry, 2 minus 1. When I is equal to 2, 2 minus 1 divided by n. 3 minus 1 divided by n. We will go on finding. So we will tabulate these values to find d plus and d minus. After finding d plus and d minus, where d plus is what the maximum value out of this, and d minus is what the maximum value out of that. So now next step is to compute the maximum out of d plus and d minus. So the maximum out of d plus and d minus will give the value called as what, d. That is the third step. Now fourth step, after finding the d value, this d value should be compared with another d value from the table 8.8. If the table the table will be given in the exam. If it is not given, the value at that position will be specified directly to the in the question paper. So this d value what we have obtained is the maximum out of these two. So one more value we need to find from the table. What is that value we need to find? D alpha comma n. D at alpha. Alpha will be given in the question. That alpha is nothing but the level of significance. Alpha is what? Level of significance. And n here is also the same thing what we have discussed in the chi-square test. That is the degree of freedom. There it was k minus s minus 1. Here only n. N already we know total number of data values. And alpha will be given. Alpha is nothing but the level of significance. So we need to find the value at d alpha comma n from table A8, and we need to compare that value with the given d value. If the d value what we obtained is less than the value in the table in A.8 at alpha comma n, then the hypothesis is accepted. Else, sorry, if it's less than or equal to, the hypothesis is accepted. If d value whatever we obtained is greater than d alpha comma n, then the hypothesis is rejected. That means what, the numbers are not uniformly distributed. So keeping this procedure in mind, I will solve one problem so that this procedure becomes clear. So let us begin with this. Let us begin with this. The question is as simple as this. Apply goodness of fit test to check whether random numbers are uniformly distributed over a period of 0, 2 for an interval 100. Take alpha is equal to 0.05. Simulation table for critical values are as given. See, it's very important. Sometimes in the question he may not say anything about Kulmagara, but or he may not mention the KS test. If he had to check out this word, uniformly distributed. When he find this uniformly distributed word is given, so that is exponential here. So we need to use Kolmogorov experiment test to check whether the random numbers are accepted or rejected. So these are the table given. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Totally he has given 10 values. So these 10 values according to the first step, we need to calculate RA, that is inter-arrival points. So let us write down. So what is given? Alpha is given as 0.05, and there are total number of 10 values are there totally. So I am writing n is equal to 10 here, right? So the number of data values or degree of freedom is what? 10. N is what? 10. And the interval given will be represented as t. T is equal to 100. Interval given is written as t is equal to what? 100. So the first step we are calculating Ri. So when I said already I ranges from 1 to n. Are you getting? I ranges from what? 1 to n. So therefore, what will be R1? R1 will be T1 by T. Are you getting me? R1 will be what? T1 by T. So let me write this. R1 is equal to T1 by T. So R1 T1. What is T1? T1 is the first data given by T. T is the, already I said, interval given. So in the question he has given interval as 100, that is T. So 0.04 by 100 will give me 0.004. Similarly, what is R2? So the R2 value will be, according to the formula, T1 plus T2. T1 plus T2 divided by T. T1 plus T2 divided by T. That is, T1 is the first value and T2 is the second value divided by T. This one will get. Similarly, R3 will be T1 plus T2 plus T3 divided by T. R4 will be T1 plus T2 plus T3 plus T4 divided by T. R5 will be T1 plus T2 plus T3 plus T4 divided by T. Like this it goes. So directly I will be telling the value. You calculate R2, R3, R4. So directly I have come to the R10 value here. R10 value is equal to, what is R10 value here? One second. R10 value. Yeah, this is the R10 value. Directly I have given R10 value. R10 value is equal to T1 up to T10 plus then divided by T. So I will be getting 0.1502. That completes the first step. That means what we have found, all the class inter arrival points, that is from R1 to R10. So R1 to R10 values are this much. So I have shown this value and the final value. This directly I have put the values, but you need to show all the details in your exam. Now step 2 is we need to calculate D plus and D minus. What is D plus? Maximum out of I by n minus Ri. So we know I ranges from 1 to n and n is the total number of data. N total number of data we have 10. So therefore I ranges from 1 to 10. So we need to calculate from 1 to 10. I value ranges from 1 to 10. Ri is what? Already we calculated. R1 is this, R2 is this, R3 is this. So up to R10 we calculated. Just I am writing that. Now as this formula has I by n, so I will be doing I by n. I value initially is what here? 1, n value is 10. 1 by 10 is 0.1. I value is 2, 2 by 10, 0.2. I value is 3, 3 by 10, 0.3. Like this it comes. Finally 1 by 1 it will be 1. Right? Sorry, 10 by 10 it will be 1. As when I is 10 and n is already 10, so 10 by 10 it will be 1 finally. So after doing I by n, which is required in this formula, so I will be doing this also here, because I minus 1 by n is required in the second formula, so I will be doing that also here. I minus 1, what is I value? Initially for this point 1, 1 minus 1 is 0, 0 by 10 is 0 itself. Now next I is equal to 2, 2 minus 1. 2 minus 1 is 1. 1 by 10, because n value is 10, is 0.1. Are you getting me? So similarly all the values are calculated. Now according to this formula I need to find the maximum out of 1 by n minus Ri. So 1 by n is already there, sorry, I by n is already there, I by n minus Ri. So what is I by n value for this? 0 0.1. 0 0.1 minus 0.0044 will give me 0.096. Similarly 0.2 minus R2, that is 0.0097 will give me this value. 0.3 minus 0.031 will give me this value. So we'll get all these values. So these are the actually I by n minus Ra values. So actually what is our D plus? D plus is maximum out of that, max out of that. So out of this the maximum value is 0.8498. That will be my D max. Similarly I need to find out, I need to subtract Ri minus this value. So 0.004, 0.0044 minus 0 is this much. So 0.0097 minus 01 is this. So all the values are written. So out of this, which is the maximum value, that will be my D minus. The maximum value is 0.0044. The step 3 is, I need to find out which is the maximum out of these two. Step 3 is what? Max out of D plus and D minus. So the max out of these two value is 0.8498. Therefore, that is the D value we got. Now after calculating this D value, our fourth step is we need to check, we need to compare this D value with the value of the D of alpha comma n from table A8. So what is alpha given? Alpha given is 0.08 and n is the total number of data, that is the degree of freedom, that is n is equal to 10 here. So we need to find the value from table A.8 from at D of 0.05 comma 10. So if you see this D of 0.05 comma 10, we will be getting 0.410, will be getting 0.410. Fine. So after this we need to check the hypothesis or null hypothesis. That is what we need to compare, that this d value and the value at in this position from the table. So the value obtained is what? 0.8498, that is 0.8498. We need to check whether this value is lesser than or equal to the value at present at this position. What is the value present at this position? It is 0.41. So therefore, this value is not less than this value. So therefore, the hypothesis is not accepted. That means what? The hypothesis is rejected. That means what? The final conclusion is the random numbers or the input are not uniformly distributed. So how to check this value? D of 0.05 comma 10 from table A8. Just check out here. The first value is alpha, that is the level of significance, and second value n is the degree of freedom. So where is this is A.8 table. So D of 0.05, this column we need to check, and degree of freedom n, there we have used small n, here it is capital N in the table A.8. So the degree of freedom what we got is what is given here, what is n value? N value is 10 here, right? N value is 10, so the degree of freedom is 10. So from this column, and what is 10? 10 is here. So I need to check this value, right? Degree of freedom is 10 and alpha is 0.05. This is the value. So what is I am getting? I am getting 0.410. That's what I have taken here, 0.410. So therefore 0.410 is actually uh, lesser than 0.8498, right? Therefore our hypothesis will be rejected. That is our conclusion. So students, this completes very important problems from the module 4. Almost all module 4 is completed. There are few terminologies which are very easy to go through, but I will discuss that also. These problems, that is Kolmogorov-Smirnov test as well as chi-square test, again the same problems will be repeated in module 3 also. So these problems can carry lot of weightage in terms of your examination, so that you can score good marks. Just you have to ponder over these problems, you have to solve these problems, and any doubts are there, I'll be contacting you through Zoom classroom. So we'll discuss, we can also discuss there. So let us see few of the terminologies. What is so there is one more problem, so I will give you directly, you can solve that. So selecting input models without data, right? Sometimes what happens when you are selecting the input model, the data may not be available, right? So unfortunately, it is often necessary in practice to develop a simulation model for demonstration purpose or preliminary study, right? Before any data are available, correct? Before any data is available. In this case, the modeler must be resourceful in choosing input models. That's what it depends upon the model's ability. What data he has to select, what type of data he has to assume. It depends upon the caliber of the modeler who is going to simulate the system, right? And must be carefully check and sensitivity of the results of the model, right? If you are selecting an inappropriate input data, Definitely, the result may not be appropriate. So it depends. It's a very important step. For example, right, if the engineering data is there, often a product or a process has performance rating provided by the manufacturer itself. Correct or not? So that data we need to keep in mind when we are trying to take engineering data. The data will be normally given by the manufacturer. So if the data is not available, this is one option. What is that? You can take the engineering data provided by the manufacturer, and if the data is not available, we can go with expert opinion. Talk to people who are experienced with the process, or get get the inputs from them. Try to find out what will be the appropriate input model, and physical or conventional limitations are also there, right? Most real processes have physical limitations on performance because of companies policies. There may be upper limits on how long a process may take, or not. Ignore obvious limits or bound, right? That narrow the range of the input process. This will narrow the range of the input process, because according to the company's processes, they may not share the data sometimes. Lot of problems. The nature of the process, it can be used to justify the particular choice when no data are available, right? The nature of the process also we can take. So their next topic is multivariate and time series input models. So what are the input models for multivariate and time series? So these are other type of input models. There is no much to solve problems or something kind of thing. Just we need to remember some facts, some results about this. The random variables represented were considered to be independent, right, of any other variables within the context of the problem. Yes, we consider that the random variables are independent, but however, variables may be related. That is called as autocorrelation. We will not be knowing it. Actually, getting the point, right? Variables will be related, and if the variables appear in the simulation models as input, the relation should be determined and taken into consideration. Whatever the variables we are giving as input, their relation also, if they are related, they should be taken into consideration. The relation should be taken into consideration. For this, we will generate z1 and z2 independent standard normal random variables, and we will set x1 is equal to this and x2 is equal to that. So these are some of the facts we need to remember when you are trying to model the things. The next topic, time series input model. If you take a sequence of numbers like x1, x2 up to xn, they're identically distributed but independent and covariance stationary random variables, then there are a number of times series model can be used to represent the process. Two models that have the characteristic that are autocorrelation take form, right? The autocorrelation takes this form, right? P of H is equal to correlation between xt plus comma xt plus h. That is equal to P of H. So we'll see about autocorrelation in the following models. A of R model, this consider this analytics. So where t is equal to from for t is equal to 2 to n, right? Where epsilon 2 and epsilon 3 are independent variables and identically distributed with mean 0 and variance sigma 2 of epsilon, right? So all these points we need to remember if you are trying to model the things with your data, whatever the data you are using, all these points are remembered. And there is one more chapter in this module, that is output analysis of a single module. Actually, this is a continuation of estimation of absolute parameters. Continuation of performance is one of the chapter there in the test work. This chapter is divided into some topics from these chapters are there in module 5 and some chapters are there in module 4. So which are the topics which are there in module 5? This is output analysis of single module. So estimate system performance via simulation, right? So actually we have done till now, we have estimated some parameters, whatever we have estimated till now, I think so. We have taken mean and normally in chi-square test and as well as in Kolmogorov experiment test, we have taken means. Correct or not? So such of parameters, what type of parameters, what are the things we need to consider, we will see. The type of simulations, there are different types of simulations, terminating versus non-terminating simulations. Terminating simulation, definitely they will terminate after some times, right? Stochastic nature of output data, the data also can be of stochastic nature. Already we discussed about what we mean by stochastic nature. Stochastic nature means which involves some random numbers which we don't know, which are not sure, right? So stochastic nature can also be there in the output model, right? Model which consists one or more random variables, are called as what? Stochastic models, because the model is an input output transformation and the input variables are RVS. If the input models are having stochastic nature, definitely sometimes the output will also be stochastic in nature. For example, if you take m slash g slash 1 queuing example, uh, this might be the parameters where the output data is also will be of stochastic nature, right? So measures of performance, consider the estimation. So there are point estimators sometimes, and there are even confidence interval estimations, and there are two confidence interval estimations, a measure of error and one more is normal distribution. So students, please go through all the topics, don't leave any topic, especially the programming, the problematic part, that Kolmogorov-Smirnov test and chi-square distribution, chi-square test. Those carries a lot of weightage, and you can contact me through Zoom or you can contact me personally. So I'll clarify your doubts. So that ends module 4 from my side. I'll be sharing you the material and all the related questions, so you can go through and complete your assignments. Thank you, one and all.